All right, welcome, ladies and gentlemen. This is video number 5 in our redox unit. In this video, I'm going to be talking about how to very quickly identify a redox reaction, which is a very common multiple choice question on the Regents, and also talking about things called oxidizing and reducing agents. So you need your notes open to page 13 for video number 5. So first up, identifying redox reactions. Now remember, a redox reaction is any reaction where there is a change in charge, where oxidation number changes. That automatically makes it a redox reaction. That's the identifying feature. Now, very typically, 3 types of reactions are redox reactions: synthesis, decomposition, and single replacement. But they don't have to be. So it's common that a synthesis reaction is a redox reaction, but not necessarily. What you have to do is check the change in oxidation number. If the oxidation number actually changes, then yeah, it's going to be a redox reaction. But if you have a synthesis reaction or something that appears to be a synthesis reaction and the charges actually aren't changing, then it's not a redox reaction. So these are things that are typically redox, but you have to check the change in charge. Now, luckily, there's actually a really easy way to tell if oxidation number is actually changing. And there's sort of a little trick here. The trick is this right here. If an element is by itself, meaning if it's alone, meaning if its oxidation number is 0 on one side of the reaction, either reactants or products, but that same element is combined, it's in a compound on the other side of the reaction, i.e. its oxidation number is not 0, then you have a redox reaction. You look for things that have an element alone on one side, but they're not alone on the other side of the equation. So this is an example right here, this sodium and magnesium chloride example. Notice how we have the sodium here, it's alone. Also notice that it doesn't have a charge, so it's alone, and its oxidation number is 0. But then on the other side, our sodium is not alone. And we know that oxidation numbers, when things are in compound, basically that they're not 0. So the oxidation number is not 0. In fact, it's +1 here because it's group 1. But we don't have to know that it's +1. All we have to know is that, hey, over here the oxidation number is 0, but over here the oxidation number is not 0. That means that the oxidation number changed, and that's what makes it a redox reaction. So kind of that's what we're looking for. Also notice in this reaction we have actually the exact same thing with the magnesium, because over here the magnesium is alone. So its oxidation number is equal to 0. But here, the magnesium is in a compound, i.e. its oxidation number is not 0. That indicates that we have a change in charge. That indicates that our charge is changing, and if charge is changing, we have a redox reaction. But be very careful, though, because the Regents will try to trick you with this. The element has to be 0 on one side, i.e. no charge. And I'm going to show you what I mean by that with the next couple of examples. So, which of the following are redox reactions? This first one, HCl plus NaOH yields H2O plus NaCl. This is not a redox reaction. Notice that there are no elements that are completely alone, no elements that are completely by themselves. That is a really quick way to say that there is not going to be a change in charge. Versus the next reaction, magnesium plus oxygen yields 2MgO. This is a redox reaction because the magnesium and the oxygen, these guys are alone, so these guys have an oxidation number of 0 on one side, but then they're in a compound, so they're not 0 on the other side. Next one, 2NH4Br plus Li2CO3 yields 2LiBr plus NH3 plus H2O plus CO2. Well, it's a really long reaction, but notice that there are no elements that are by themselves, no uncombined elements, no alone elements at any point. Everything is always in a compound. So that's not going to be a redox reaction. Now, next one is really the one where I'm gonna get you if you're not paying attention, because you're going to see this hydrogen, and you're like, hey, this hydrogen right here, it's alone. Well, yes, it's alone, but notice its charge. It's alone, but its charge is not 0. This thing has a charge of +1. And over here, it's in a compound, which means its charge is also +1. So although the hydrogen is by itself, its oxidation number is not 0 on the left side. So it is not a redox reaction. Charges are not changing. The hydrogen starts at +1 because it tells you that. It literally says that. The H starts at +1 and it ends at +1. So it's not a redox reaction. The last one, however, is a redox reaction because this chlorine is by itself on one side and it is not by itself on the other side. So it will be a redox reaction. So this is like an example that I pulled from essentially multiple choice. Identify which of the following are redox reactions. The silver nitrate, potassium chloride. This is a big fatty no. There are no alone elements. LiBr yields Li +1 plus Br -1. This is also not a redox reaction because it's not zero. Elements aren't zero. They have to be alone and have no charge, have a charge of 0 on one side, which this doesn't. So if there's a charge, that really overrules it because the charge here in this lithium in this compound is +1 and the bromide is also -1. So the charge did not change. That makes it not a redox reaction. The next one, however, yes, this is going to be the redox reaction because not only is this calcium alone, but it also has no charge. Likewise, the oxygen is alone and has no charge, but then the charge is not 0 when it's in the compound. In fact, the calcium is +2 and the oxygen is -2. So this is a big fat yes. The next one isn't. Potassium hydroxide plus hydrochloric acid yields water and KCl. Again, there's no element that's alone on one side and not alone on the other side, so it's not a redox reaction. The last one might be there to trick you because you're saying, oh, well, the calcium's alone on one side and it's in a compound on the other. Yes, but the calcium has a charge on this side, so it's not 0. So it starts at +2, but then it ends at +2. The charge is not changing, so that is not a redox reaction. And the next topic, oxidizing and reducing agents. In order to understand what oxidizing and reducing agents are, I think it's helpful to talk about travel agents because a lot of people are familiar with travel agents. They know what travel agents do. Travel agents are professionals who help you plan a trip. But they don't actually travel with you, meaning they help you travel. They book a hotel, they book your flights, they give you information about the place you're going to go see, they help you find interesting things to do, but they don't actually go on the trip with you because that would be weird. So travel agents, professionals who help you travel, but don't actually travel with you. If you get that idea, then you can understand what oxidizing and reducing agents are. An oxidizing agent is a reactant, and this is actually really important. Only ever going to be a reactant, not a product. It's a reactant, atom or ion, that will help something become oxidized, meaning it isn't actually oxidized itself. An oxidizing agent, it helps something be oxidized. It itself is not oxidized. Well, how can you help something be oxidized? Well, what is oxidation? Oxidation is the loss of electrons. You can help something be oxidized by actually taking its electrons. I can help you lose your money if I come along and steal your money. Because if I steal your money, I'm helping you lose money. So what am I doing if I'm taking your money? Well, I'm gaining money, right? Well, if we replace the word money with the word electrons, the oxidizing agent is actually the thing that is reduced because it helps something else be oxidized by actually taking its electrons. And if we gain electrons, that is the definition of reduction. So I know it's a kind of weird thing in terms of the words being used. They're sort of opposite, but an oxidizing agent is something that helps something be oxidized. It itself is reduced. So the oxidizing agent is the reactant that is reduced. Similarly, reducing agent is simply the flip of that. The reducing agent, again, it's the reactant, not a product. Products are never things that are oxidized or reduced. Only reactants can be oxidized or reduced. The reactant atom or ion that helps something else become reduced. It itself is not reduced. It helps something else be reduced. It helps something else gain electrons. Well, how can I help you gain money? I can give you some of my own money, right? I can lose some of my own money. Again, replace the word money with electrons, and the thing that is the reducing agent is actually oxidized. It helps something else gain electrons by giving it its own electrons. So it loses its electrons itself. So we're just going to look at two problems with this. In the reaction shown there, the oxidizing agent is what? So interpreting the problem, if it asks for the oxidizing agent, that means it's asking for the reactant that was reduced. So right away, because it's asking for a reactant, your choices are limited to these two things. So I'm going to cross off things that are products, basically things that are not reactants. Right, I'm limited to the H2 and the O2. Then in order to figure out the thing that was reduced, I need to assign oxidation numbers for the elements in the reaction and figure out how they changed in charge. So the hydrogen is alone on the left, so it's 0. The oxygen is alone on the left, so it's 0. So both of these guys start at 0. But then what do they end at? So I have to assign oxidation numbers for the water in the product. Hydrogen is usually +1 in a compound. Oxygen is usually -2 in a compound. So the hydrogen goes from 0 to +1. The oxygen goes from 0 to -2. Going from 0 to +1, this is an increase in charge. That means it's oxidation. Oxidation is a loss of electrons, which makes your charge go up. The oxygen went from 0 to -2. That is a decrease in charge. Charge got lower. How does charge get lower? Well, if you gain electrons, then charge will go down. That is the definition of reduction. So we are looking for the thing that is reduced, which means we are looking for the oxygen, but we are picking the reactant option because it's always going to be a reactant, so we're going with O2. And then just one more problem. In the reaction zinc plus Fe2 plus yields zinc 2 plus Fe. The reducing agent is what? Okay, reducing agent, what does that mean we're looking for? It means we're looking for a reactant. The reactant that is oxidized. So we're going to use the same process here. First of all, I want to limit myself to the reactant options, zinc and iron 2 plus. So I'm going to cross off the choices that are products. These guys are not going to be my answer. I want to only choose reactants for things that are oxidized or reduced. And then I need to assign oxidation numbers. The zinc starts at 0 because it's alone, and then it ends at +2. The iron starts at +2, and then it ends at 0 because it's alone. And then I think, okay, which of these is oxidation, which of these is reduction? The zinc increased in charge. The iron decreased in charge, which means that the zinc was oxidized and the iron was reduced. For this problem, I want the reactant that was oxidized, so the correct choice is the zinc, the reactant zinc. So we're going to be practicing in a problem set with the half reaction method and then also these types of questions.